0 milliseconds. That's what you asked for, but that's not what you got. So you check the output. Wrong order. You read the code again. Nothing's wrong with it. Same code, same moment, but different result. Something decided the order. The loop runs tasks from a queue. You know that. But two tasks arrive at the same moment, and one cuts ahead. Not randomly, something decides before your code even runs. One queue, first in, first out. That's what you'd expect. But the system works differently. There isn't one queue, there are two. Two types of tasks: timers, IO, events, the ones you'd expect. And then another kind: promise callbacks, queue microtask. We call them macrotasks and microtasks. Same loop, different rank. So after a macro task finishes, the loop drains the microtask queue completely. Every single one runs before the next macro task gets a turn. Not some of them, all of them. No exceptions. Same pass, but now there's a clipboard. VIP orders. After every task, the chef checks the clipboard. If there is a VIP order, it goes next. Regular orders wait, even if they were there first. Not unfair, it's just the rule. Set timeout, 0 delay. Promise resolves immediately. You'd expect A first, but you get B. Not because it's faster, because it has priority. The promise callback is a microtask. It runs before the next macrotask, even if the macrotask was scheduled first. But what if the VIP orders keep coming? The chef never looks up, and regular orders pile up. The kitchen is working, but nothing is being served. That's what happens when a microtask creates another microtask. Timers don't fire, events don't process. The loop is alive but stuck. Async is not about speed, it's about order, and that order is controlled. So you stop asking, will this run? And you start asking, when will this run? That question changes everything. Microtask runs, microtask queue drains, next macrotask, repeat. That's the full cycle. One rule, one priority, applied every single time, whether you see it or not. Most developers don't think about order. They write async code and assume it doesn't matter. It matters. And now you know why. One more thing. You write await. The function stops, but the loop doesn't. Something runs during that pause. That something is how async actually works.